Hello. Let us discuss about the power of operational amplifiers. Operational amplifiers are known as op-amp, all of us know, and we have taken a operational amplifier LM358. Usually the operational amplifier, the non-inverting input, that is this, has to be given a biasing, and generally they are of same value. Here we are given a 47K and another 47K and given a biasing. To the inverting input is the real amplifier, and for the inverting input we have connected a feedback of 60K resistor from the output to the input, and a resistor, a 10K, is connected in series with a capacitor, and a supply of 1 volt sine wave is given. We will see how the gain is governed by R2 by R1, that is R2 by R1, and R2 is equal to 60K and R1 is 10K, so the gain is 6. That means if I give 1 volt here, I'll get 6 volts here. This is what basically is the operational amplifier, and we will see that how it works. Now when I power this green one is the 1 volt. You can see this is in the 1 volt scale, and in the 1 volt scale it gives from here to 1 division, that is 1 volt. This gives the 1 volt, and the output from here, this is in the also 1 volt scale, and it gives from here 1, 2, 3, 4, 5, 6. It gives 6 volts AC, and this is what is the operational amplifier function as far as the gain is concerned. We can see a few more systems. Supposing I change the gain, instead of 60. Now supposing I change the gain to say 40. Sorry, 40 by 10, it will be 4. Now let's see how will be the output. Now the output is 1, 2, 3, 4. Now this is what is actually the function of operational amplifier. So whatever the value of this particular feedback, that is R2 to R1, get back to 6, R2 to R1 decides the gain of the operational amplifier. It is as simple as that, and the biasing has to be done this value. And if you look at the little documentation, it says it's the single, normally it's a dual power supply people follow, but opens can easily be configured to a single power supply by use of a resistor network. In the above example, we have R3, R4 plus a voltage of half of the voltage supply voltage. R3, R4 plus half of the supply voltage across the non-inverting input, this is this one, this is the non-inverting input, which causes the output voltage also half of the supply voltage, forming a sort of bias voltage. R3, R4 can be any value from 1K to 100K, but in all cases they should be equal. An additional 0.1 microfarad has been added here. Okay, we have forgotten here. In fact, one more additional capacitor can be added here. I'll go here and then we'll add that 100 nanofarad capacitor. 100 nanofarad capacitor, 100 nanofarad capacitor, 100 nanofarad, 100 nanofarad, 100 nanofarad, chip 47, 100 nanofarad capacitor. It can be used across this to ground. Okay, so what we do is we can use this 100 nanofarad capacitor here and connect it to this place and this place, and still the output that we get will still get the same value, and that is how it works as far as the operational amplifier is concerned. And so we will go back to the document again. That's what a 0.1 microfarad has been added to the non-inverting input to reduce noise caused by this configuration. The use of coupling capacitors for input-output is required for this configuration. Coupling capacitor means this is the coupling capacitor for the input and this is the coupling capacitor for the output. Setting the gain of the operational amplifier. The gain of the circuit is determined by R1 and R2. This is calculated by the following equation. The voltage gain is equal to R2 by R1. R2 by R1. The R1 can be any value from 470 to 10K, but the op amps have input impedance as high as several 100,000 ohms or greater. Any input power lost through R1 is insignificant. R2 can be any value from 10K to 1 megohm. R2 means this one, the feedback resistor, can be any value. R2 actually limits the gain of the operational amplifier by providing a form of negative feedback. The op amp typically has a voltage gains between 20,000 to 200,000. In case should the voltage gain be set by R2 and R1 be greater than 1000. In no case it should be more than 1000. The voltage gain is essentially independent of supply voltage. So that is what is the function of the operational amplifier in nutshell. It is very simple, but it is independent of the supply voltage. Now supply voltage is 18 volts. Now, okay, now supposing even if I change the supply voltage to say 24 volts, to 24 volts, the function still remains same gain 1, 2, 3, 4, 5, 6, and this input is same 1 volt. Thank you.